Hello, welcome to how to solve this very nice square root math simplification problem. Square root of 10 plus square root of 24 plus square root of 40 plus square root of 60. This expression is equal to square root of 10 plus, we can write this square root of 24 as square root of 4 times 6 plus, we can write this square root of 40 as square root of 4 times 10 plus, we can write this square root of 60 as square root of 4 times 15. Next, square root of 10 plus this square root of 4, square root of 4 is equal to 2. So we can write this square root of 4 times 6 as 2 times square root of 6 plus, we can write this square root of 4 times 10 as 2 times square root of 10 plus, we can write this square root of 4 times 15 as 2 times square root of 15. Next, square root of 10 plus 2 times square root of, we can write this 6 as 2 times 3 plus 2 times square root of, we can write this 10 as 2 times 5 plus 2 times square root of, we can write this 15 as 3 times 5. Next, square root of 10 plus 2 times, according to this property of exponents, square root of a times b is equal to square root of a times square root of b. We can write this square root of 2 times 3 as square root of 2 times square root of 3 plus 2 times, we can write this 2 times 5 as square root of 2 times square root of 5 plus 2 times, we can write this square root of 3 times 5 as square root of 3 times square root of 5. Next, square root of, now we notice that here we have square root of 2 times square root of 3, and here we have square root of 2 times square root of 5, and here we have square root of 3 times square root of 5. Now if we suppose that a is equal to square root of 2 and b is equal to square root of 3 and c is equal to square root of 5, then this expression 2 times square root of 2 times square root of 3 is same as 2 times a times b. This expression 2 times square root of 2 times square root of 5 is same as 2 times a times c, and this expression 2 times square root of 3 times square root of 5 is same as 2 times b c. and here we have plus, and here we have plus. So here we can complete the square by using this algebraic identity a plus b plus c whole squared is equal to a squared plus b squared plus c squared plus 2ab plus 2ac plus 2bc. And in this expression we have 2ab plus 2ac plus 2bc. We just need these three terms, a squared plus b squared plus c squared. So we write this 10 as this 10 is equal to square root of 2 squared plus square root of 3 squared plus square root of 5 squared. And this square root of 2 is equal to a, and this square root of 3 is equal to b, and this square root of 5 is equal to c. So we complete the square by writing this 10 as square root of 2 squared plus square root of 3 squared plus square root of 5 squared. This whole expression is equal to this 10, and then we write this remaining expression plus 2 times square root of 2 times square root of 3 plus 2 times square root of 2 times square root of 5 plus 2 times square root of 3 times square root of 5. Now this square root of 2 squared is same as a squared plus this square root of 3 squared is same as b squared plus this square root of 5 squared is same as c squared plus, and this 2 times square root of 2 times square root of 3 is same as 2ab plus this 2 times square root of 2 times square root of 5 is same as 2ac plus this square root of 2 times square root of 3 times square root of 5 is same as 2bc. It means we have a perfect square in this form: a squared plus b squared plus 2ab plus 2ac plus 2bc. So we can write this whole expression in this form as a plus b plus c whole squared as square root of, we have a as square root of 2 plus, and we have b as square root of 3 plus, and we have c as square root of 5, and we write it whole squared. Next, this square will be cancelled with this square root, and here left square root of 2 plus square root of 3 plus square root of 5, and this is the required simplified form of that expression. So this expression is equal to square root of 2 plus square root of 3 plus square root of 5.